Current AI agents face a strict mechanical limit. Despite their processing speed, they operate on a single rigid track, handling one prompt, performing one action, and waiting for the next command in a linear loop. You see this friction in codebase refactoring. To update a project, the AI must edit a file, run the compiler, hit a syntax error, read that error, and attempt to fix, one painstaking step at a time. Over multi-hour sessions, this sequential processing creates a buildup of errors. As the working memory fills and the prompt cache breaks down, the agent eventually loses the thread of the architecture and begins to propose hallucinations that don't fit the broader project. High-stakes enterprise deployment requires more than raw intelligence. It requires throughput. A model that gets lost on step 42 of a 50-step process is not viable for production-scale workloads. To solve this bottleneck, Claude Opus 4.8 introduces dynamic workflows, allowing the model to operate as a fully autonomous, multi-threaded engine. Engineering at an enterprise scale requires handling hundreds of interlocking dependencies simultaneously, a level of complexity that a single-threaded loop cannot resolve. Handling a full codebase requires a shift in how an AI organizes its labor. This is the logic behind dynamic workflows. This diagram shows the orchestrator node in action. When tasked with a project, like migrating a 450-service microservices platform, the orchestrator evaluates the entire repository and decomposes the goal into hundreds of non-blocking, independent tasks. The orchestrator then spawns hundreds of parallel subagents. Each one is assigned a specific slice of the work to execute and verify simultaneously. These subagents work within isolated environments. They can edit files and run localized test suites without interfering with other agents or creating a bottleneck for the rest of the team. Once their specific tasks pass verification, the subagents report back to the orchestrator. The hub checks the outputs against a master test suite and performs the final merge into the unified codebase. This parallel architecture treats the AI as a distributed engineering team, executing and verifying code in tandem rather than in isolation. At the individual agent level, Anthropic has introduced adaptive thinking. Controlled by an effort parameter, the model now dynamically decides how much compute to allocate to any given turn. For a basic file retrieval or a simple lookup, the model bypasses deep reasoning entirely. It responds directly, which minimizes both latency and token usage. But when the task involves fragile logic or database migrations, the model shifts. It allocates a massive reasoning chain to work through the problem before it takes its first action. This is part of a broader push for epistemic calibration. Opus 4.8 is 4 times less likely than its predecessor to let flawed code pass without flagging the error. Some early feedback suggested the model was being lazy by stopping frequently. In practice, this is a strict honesty protocol. When the model encounters a flawed assumption, it is designed to pause and ask for clarification rather than attempting to guess a solution. In a production environment, an AI that catches its own uncertainty and stops the loop is more useful than a model that confidently reports a successful hallucination. To function autonomously, these agents need to see the entire project at once. Opus 4.8 operates within a 1 million token context window, enough to ingest massive data vaults and full repositories. This chart shows the GraphWalk's BFS benchmark, which measures reasoning across 1 million tokens. Opus 4.8 scores 68.1%, a significant lead over GPT 5.5's 45.4%. Long-running workflows present an economic challenge, updating instructions without reprocessing everything already learned. Opus 4.8 allows mid-conversation system messages. Developers inject updated instructions mid-flight, and because the prompt cache remains intact, the AI skips rereading the original million tokens. Maintaining context while steering the model makes long-horizon autonomous work economically sustainable for enterprise scale. These capabilities translate directly into the benchmark data. While GPT 5.5 leads in terminal-heavy shell automation, Opus 4.8 leads on SweBench Pro, the benchmark for repository-level engineering, with 69.2% compared to OpenAI's 58.6%. Enterprises are already applying this efficiency. Databricks Genie uses the model for database schema analysis at a 61% token discount compared to previous generations. At Hebbia, the model performs financial audits with citation precision that matches exact page coordinates, significantly reducing the need for manual human verification loops. With the addition of a new fast mode, companies can now access this logic at 2.5 times the speed and a third of the previous cost. By prioritizing verifiable output and high-volume orchestration, Opus 4.8 looms AI beyond basic conversation and into the role of a trusted, autonomous production agent.